Hey, Science Nine's Manchak here with your Concept E3 video lesson. So today I'm going to run you through, hopefully relatively quickly, what you need to know for Concept E3. So what I'm going to do this week that's different from the last 2 weeks is based on the feedback that I had in the survey I put out. You guys actually preferred my old way of doing things, which I guess is fine. So I'm going to record sort of a full-on run through the notes kind of thing with highlights and all of that kind of stuff. So that is what I am going to do for you guys today. So we're going to switch back to the old way of doing things. So you'll have a longer video from me. But I think I'm going to add in a short, hopefully 3 or 4 minute rundown of what I think is the most important stuff you guys need to know. Just a short extra video that I'll tack on to the end of this for you guys. So yeah, that's where we're at. So we're going to get started right away. Concept E3 is continuing on with what we've been doing in our space unit so far. So to this point, we've gone through and talked about our early views on space, some technology that was used to discover more about space and history, those kinds of things, as well as matter in space. We talked about galaxies and star systems and all of those other kinds of things. We talked last week about our solar neighborhood, talked a little bit about our planets, orbits, those kinds of things. We talked about comets and asteroids and meteoroids. And it was actually a really short lesson. And then we talked about how we can identify something up in space using azimuth and altitude. This week, what we're talking about is space transport, living in space, and applications to Earth. And so we're going to basically have a look at what's going on out there in the world with respect to technology that gets us up into space, then what happens when we're actually in space and the challenges associated with that, and then how we've taken what we've learned in getting ourselves up to space and being in space, and how that's actually had applications to us here on Earth, which is kind of cool. I think it's appropriate that I'm wearing my 42 shirt today because it represents life, the universe, and everything. And if you don't know what that is, maybe look it up sometime because, yeah, it's kind of spacey. Anyway, that's my nerdiness coming through. So we are going to, I've got set up for you, and this was posted just above in the Google Classroom where you found this video. So actually this week there are 10 videos. They're all really, really short videos except for this one here, the future of human space exploration. And I've created a playlist again, so if you just wanted to watch them in succession, you can. They're really excellent videos. I think all of them. There's 4 in a row with Chris Hadfield, who is an awesome Canadian astronaut. Who, if you don't know about him, you should know about him because he's an amazing Canadian. So do spend some time watching his videos because he was actually up on the International Space Station. So there's videos to accompany everything we're going to talk about today, some formative work to work on, and then a worksheet you'll be covering that covers E3 and E4. You guys only need to worry about doing Concept E3 because this is what we're working on right now. So I think that is about all I need to say at this point. So I'm going to just quickly drag in my my presentation here, hit the present button, and move myself off to the side a little bit, and we're going to work our way through the lesson for you. So we are talking about technological developments that are making space exploration possible and offer benefits on Earth. That's section 2.0 in your textbook if you are keeping score. Oh, I wanted to do one more thing actually here. Just a second. Boom. Let's get out of that for a sec. And there we go. I just wanted to move that out of the way. All right, so let's present from here. I don't know why I say present, but so there's lots of stuff you guys can read in your textbook on this. I'm just gonna cover some of the highlights that I think are most important for us to understand. So this is just a quick breakdown of some of the achievements of rocket science. Basically, the stuff that has allowed us to actually get out into space. And we haven't traveled terribly far as humans. We're really in our very close solar neighborhood, if you want to look at it that way. If you want to think about it on the scale of Earth, I would say maybe we've gotten as far as Calgary or something like that. But we haven't reached Mars as humans yet. We haven't reached in closer to the sun, anything like that. So there's a whole bunch of history that's gone on here. But I'm not going to go over all of these dates, and I'm not going to hold you to them. But what I want you to see is that, first off, some of this stuff started way back, in ancient times, and has sort of moved its way through. Right, we went from gunpowder to solid fuels in the 17th century, so the 1600s. Then in the 1900s is when really things took off, and we had a sort of a space age or space race that took place from about the 1950s on through even to present day. I think there's still some competition, but I think there's more agreement than competition right now. So all of this stuff sort of led to where we are today, and exploring space as being the sort of last great frontier to explore, although some might argue the oceans and other places are great places to explore as well. So let's talk a little bit first about how we get things up into space. Okay, that's the big one at this point. So the science of rocketry relies on basic physics principles to allow us to get these devices, these machines, these transports up into space so that we can go and explore it. Remember, the first explorations of space were done unmanned, meaning that there were no people in the spaceships. So there were animals sometimes, which is kind of interesting. But then we started to move humans up into space. These rockets work off of the principle, Newton's third law, that for every action there is an equal but opposite reaction, meaning that if we put a bunch of force downwards into the earth or into atmosphere or whatever it is, then it's going to push back against us and move us up. So we have to overcome gravity to get out of Earth's atmosphere and up into space. So we do this using rockets, and the development of rockets you saw in this previous slide sort of started back even back as far as 400 BC, and has sort of evolved as time has gone by, with us getting better and better and better technology to allow us to make rockets. And so the main structure of a rocket includes sort of three basic parts. There's the structural and mechanical elements of the rocket, which is everything from the rocket itself to the engines to the storage tanks, fins on the outside that help guide the rocket during its flight. Then the rocket has fuel inside of it, and this fuel can be any number of materials depending on the kind of rocket, where the rocket is going to go, all of those kinds of things, and this is evolving as time goes by as well. We're not seeing the same rockets necessarily today as we saw years ago. But the fuel can include things like liquid oxygen, gasoline, liquid hydrogen, and these mixtures are ignited in a combustion chamber, which causes gases to escape through the exhaust out of the nozzle that provides a downward force, which is resisted by an upward force, and it pushes the rocket up into space. And I'm going to keep it as simple as that right now. And then the last thing that we have on these rockets are the payload. And the payload refers to the materials that are needed for flight, including the crew cabins, food, water, air, people, whatever instruments or materials might be sent off to wherever that rocket is being sent to. So I'm not going to play this for you because we don't need to right now, but there's a video that I linked in your playlist for this lesson called How Do Rocket Engines Work. I would recommend, if you want to pause right now and watch it, go ahead. If you want to make that part of what you do after you've watched this lesson, go right ahead as well. But I've included this video for you in your lesson. This comes from page 412 of your textbook, and it's just a basic breakdown of what's going on inside the rocket. So we sort of talked about the three main things: payload, fuel, and the structure of the rocket itself. So in red here is the structure: the nose cone, the frame, the fins. The propulsion system includes the fuel, the oxidizer, the pumps, the nozzle. All of these things control the thrust that the rocket creates to try to get off. And then the payload system depending on the kind of rocket you're in, is usually located up near the front. That's, if it's a manned rocket, then it's going to have place for the humans to be in there. It's going to have a place for, everything the humans need to bring with them, whether that's water, food, whatever it might be. So this is what a cross section of a modern rocket might look like. So that's rockets. That's how we get people into space. Again, I'm going through this relatively quickly, and you can fill in some of the blanks with the videos. You can fill in blanks with going through your textbook as well on this stuff. So that's how we do things now. To get people into space, it's a challenge, right? We have to build these complicated machines in order to push us up into space. Once we get into space, it's really, really challenging to be up there because there's no oxygen, it's really cold, all of these other kinds of things. But once we're up there, propulsion is relatively easy in certain respects because there's not much gravity up there, and there's not much resistance, there's not much friction up in space. The problem is that also produces some challenges with respect to Newton's third law, because you need to have something there to oppose your force as well. So something for us to consider. One of the things that we talk about in this section is the future of space transport technology, and one of these things is called an ion drive, and these are engines that use xenon gas instead of some other kind of chemical fuel. And the xenon basically is electrically charged, accelerated, and then released as exhaust, which provides thrust for the spacecraft. That's what pushes the spacecraft forward. The thrust is 10 times weaker than a traditional engine, but it lasts an extremely long time, which is kind of cool, because those big chemical reactions of the liquid oxygen or liquid hydrogen or whatever we're doing, those are very exothermic, very violent reactions that happen very, very quickly, and then they burn out. What do you do? This, on the other hand, is something that can be done slowly. And once you're out in space where there's minimal gravity and minimal resistance, if you can get just enough thrust to get you going, you're good. So the amount of fuel required for space travel of this fuel is about 1/10 of conventional crafts, which is great, because then that lowers the amount of stuff you have to carry on that rocket as well, which makes it a little more reasonable for us to fire off into space. So this might be what an ion drive would look like. If you wanted to take 11 minutes right now, you could fire up your YouTube machine as well and have a look at the future of human space exploration, which I linked in the playlist as well. And it gives you an idea of what we might do to get further out into space. So sort of, expand our neighborhood, maybe get out of our neighborhood and get into other parts of space in our solar system. So it might be worthwhile having a look at this as well, if you'd like to. The other way that we can get space, or we've suggested that we can get vehicles around in space, is something called using a solar sail, and these solar sails are kind of neat as well. They use the same idea as sailboats, but sailboats. Pardon me, that's a really hard word to say. Apparently, sailboats move by the sails unfurl and they get pushed by wind. Well, we don't have wind per se in space because there's not really any air up there to push against the sails. So instead, they're harnessing solar wind, if you want to call it that. They harness the light of the sun and the sun's electromagnetic energy. We know that the sun releases a whole bunch of different kinds of electromagnetic energy in the form of photons, which are little tiny packets of light. They hit the carbon fiber sails, and it transmits the energy of those photons through the craft to propel it through space. Okay, and these spacecraft could travel up to 5 times faster than the spacecraft today because of this. Problem is when you get a little further away from the sun, it may be a little more challenging to actually run off of a solar sail. If you wanted to, I've also included a video in your playlist to have a look a little bit about what solar sails are and how they work. All I'm trying to do at this point is give you an idea of we've got ways for us to get out into space, and we've got ideas and plans to get us moving through space. That's where we're going. The biggest challenge in the 1900s was how do we get from ground up into space? Once we're up there, how do we move ourselves around space in some way that might allow us to go a little further than out to the moon or out to the space station or wherever we go. What we're going to see as we move forward here is that going up into space presents an awful lot of challenges as well, and that's what we're going to link into in a minute here. Let's talk a little bit about some of the vehicles or things that we send up into space. The science of rocketry has sent humans on round trips to the moon. They've sent robots to investigate other neighboring planets, right? You've probably heard of the Mars rover that headed out to Mars to explore that planet and is still exploring it, from what I understand now. We've even sent the Hubble Space Telescope out to look far into the universe, and it's gone a long way out into our solar system to get clearer views of whatever might be out there in space. There's three main types of spacecraft that we use to move things around space, and that things could include humans. There are shuttles that transport personnel and equipment to orbiting spacecraft. So think of it as something that goes from here to there and back. Okay, and it can do that many, many times. We had the NASA space shuttles; those have been decommissioned, but we found other shuttles that are working and making that. Mostly Russian shuttles right now that are making that happen. There are space probes. These are unmanned probes that are sent out into space, devices that are sent out into space, and they carry out robotic exploration of space. So there's no humans on there. Instead, we've got instrumentation. We got fancy computers, robots that are out there. So the Hubble Space Telescope would be considered a space probe. So would the Mars rover, right? All sent out to go do something remotely for us and then beam that information back to us. The other thing that we have are one space station at this point, the International Space Station, which orbits, and it includes living quarters, work areas, and all the support systems needed to allow people to live and work in space for extended periods. And what's really cool for sci-fi geeks like me is that these space stations are that first step in helping us as humans understand how life changes when you're out in space. And when we get to the next section, you're going to see a bunch of videos from Chris Hadfield explaining how life is different in space. And it's really quite cool and remarkable how life is different in space. The things that you may not have thought about that change when you get into microgravity, when you get into a place where there is no air and it's super cold, those kinds of things. So something for you guys to consider as we move forward. This is just an image showing the different kinds of vehicles that we send up into space, right? Shuttles, probes, and stations. Okay, so that's what that is. Moving on to the next one. So what are the next steps? Where are we going? What's happening in our world? Well, we know that there are plans for manned interplanetary space missions, possibly to Mars or to Jupiter, one of its moons in particular. You couldn't really land on Jupiter. You'd get crushed by the gravity, and we're not going to get into that. It's a pretty crushing sort of, the gravity of the situation of going to Jupiter is just, it crushes me. Anyway, so the colonization of the moon are other ideas that have surfaced recently of things that we could do for our next steps. Building a remote spacecraft launching site, like on the moon or on the International Space Station, might be the first step to enable interplanetary flight. Interplanetary means between planets. So if we for some reason were able to set up a colony on Mars, then we would probably need a relatively easy way to shuttle people back and forth. That first colony that gets sent to Mars, they're not coming back in their lifetimes. Okay, there's the technology doesn't exist, at least at this current point. We have the technology to get them out into space and fire them at Mars, we think, but once they land, we don't have the technology right now to get them off of Mars to come back. So it's kind of a one-way trip. What we might be able to do in the future is build more space stations that would put more stuff into the reaches of space, that would allow us then to explore further and further and further out. So we get a colony on Mars, we got a station orbiting Earth. We can maybe fire some people back and forth. Maybe we build a space station orbiting Mars, and then we can go a little further out and a little further out. We've even got private developers and companies that are planning planning tourist flights and possibly hotels or amusement parks even on places like the moon, which is kind of cool. And if you want to look up things like SpaceX, they are planning to do consumer stuff where people could move up or go for a trip into space and back for, I don't know, probably an exorbitant sum of money now, but maybe a cheaper amount of money in the future. So something to consider, that there's a lot of next steps. I included this video here, Mars One, a one-way ticket to Mars, just for something for you guys to have a look at. It's a really informative video about the considerations we have to make if we are making a trip in space. Okay, moving ahead then. Once we've got into space, how do we survive in space? That's the next question that we have to ask ourselves. And so I'm sure you guys know this intuitively, and maybe you've watched some sci-fi movies or TV shows that give you an idea of this, and a lot of them are relatively accurate in how they, well, somewhat accurate in how they portray space. But we know that space is a cold vacuum. A vacuum means there is very little, if any, matter in space. So there's not air to breathe, right? It's a vacuum. It's devoid of any particles, of any matter. In most places there is matter out there. Obviously planets are matter and stars are matter, but and that all matters, pun intended. But in the spaces between those planets and stars, there's nothing. Okay, and it's also super cold, right? There's nothing there to hold on to warmth. So we're talking about temperatures that are minus 250, minus 270 degrees Celsius, which is very, very cold. So as we've sent people up into space, we've needed to develop technologies that help us overcome the hazards of space as a harsh environment. So a manned flight to Mars, for example, would last 2 to 3 years to get from Earth all the way to Mars. It would take 2 to 3 years, given our current technology, to get us from point A to point B. That's a long time to be enclosed in an environment. And so as they design the plans to get people out into Mars, they have to consider a whole bunch of things, including what are the environmental hazards that people are going to have to put up with. Things like the cold of space, the lack of oxygen. They're obviously going to have to recycle oxygen. They're going to have to recycle water to make sure that people have enough water. What about food? What about the psychological challenges of living with the same people in the same tin can in space for 2 to 3 years? Think about that one for a second. What effects does this have on our bodies? And what effects does microgravity have on our bodies? What does that look like, and how can that affect us? Okay, so these are all considerations that need to be made. A couple of things about environmental hazards. We know that space is a vacuum, so there's no air or water up there. There's also cosmic and solar radiation, meteoroids. All of those things are out there that can cause major damage to a ship or to the people on the ship. Because there's no atmosphere, the temperatures in space have both extremes, from extremely hot to extremely cold. If you are parked right in front of the sun, you're probably experiencing extremely hot. But if you're parked away from the sun or on the other side of a planet from the sun, you're experiencing extreme cold at that point. There's also no atmospheric pressure. That helps regulate our heartbeats and other things, because a lot of how our internal mechanics work is based off of being on Earth at 1 atmosphere, or about 101.325 kilopascals of pressure, give or take. And so when we change that changes how everything in our body works. There's psychological challenges we talked about. Long trips can present psychological difficulties, such as the claustrophobic feeling of tight living conditions. I'll tell you, for one thing, I could not do it. I do not like small spaces, and that would drive me absolutely nuts. So it would definitely not be something I would explore. The other thing that's really interesting is that the space, and we're starting to discover this, has significant impacts on our human body. So living in microgravity, which is very, very, very tiny amounts of gravity, because everywhere in space there is gravity, just really small when you're not close to a planet or a star, that causes problems. This weightlessness affects the human body. Bones have less pressure on them, so they start to expand a little bit. They can also lose calcium and become more brittle, meaning they could break a little easier. The heart doesn't have to pump as hard to circulate blood, so that changes the heart a little bit. Because of the weightlessness, we're not resisting the pull of gravity on us, so our muscles weaken and shrink. Depth perception is affected. And so I would invite you to have a look at this video at some point on Chris Hadfield talking about eyesight in space and how that changed according to his experience as he spent his time on the space station. The other thing that we've had to do is to develop a suit, a space suit that allows us to move around in space if we have to repair a vessel, if we have to repair the International Space Station. We need to protect those astronauts from the harsh environment of space. So what these spacesuits do is provide atmosphere for breathing. It provides pressurization of the atmosphere so that we can breathe normally, protects us from heat, cold, and micrometeoroids, which are the little tiny particles that are moving super, super fast, but could be enough to damage you if they hit you, even though they're very, very small. And obviously contains a communications link. So you can see this is Commander Chris Hadfield over here wearing his spacesuit, and you can get an idea of what it looks like. I have another picture in a second here. They're worn by astronauts during all critical phases of the mission, during periods when the command module is not pressurized, and during all operations outside the command and lunar modules, whether in space or docked at the International Space Station or on the moon. So here's an example of sort of an evolution of what these sort of spacesuits might look like. So you've got our Apollo spacesuits from the 60s and early 70s. We've got 1982 to present. Okay, well this some of this stuff is a little older, so not present as in right today, but something that Chris Hadfield might have worn. And then this was the projected things that we're already past 2015 now that we might have ended up with. And we can see the designs have changed a little bit. Maybe they've become a little less bulky, a little easier for the astronauts to move around in, those kinds of things. When we created this, the space station, we had to create life support systems to artificially produce stuff that we needed. So clean air, clean water, fresh air, comfortable temperatures, and air pressure are all essential to life when you're living out in space. And all these support systems, including a power supply to operate them, must be operational on the International Space Station at all times. If they're not, we got problems. And it's not easy to just call an ambulance or call a repair guy and have it fixed. And that's really cool. If you ever get a chance to read any of Chris Hadfield's books about his life, sort of his autobiography kind of thing, you should, because he talks about the intense training that astronauts need to go through in order to go to a place like the International Space Station, because he's a researcher. He's studying the effects of humans on space while he's out there. He's an engineer. He's trying to figure out how to fix problems as they arise, right? You have to be a bit of a doctor because you have to take care of yourselves. You can't just pick up a phone and say, hey, can I make an appointment to come and see you? Because you are in space. You're not coming back down to Earth in a split second to go see the doctor if something goes wrong. So you have to be this incredibly well-rounded individual who knows a lot about a whole bunch of different things in order to make this happen. So it's really cool when you think and read a little bit about what these astronauts need to go through. So how do we take care of some of the basic necessities when we're up in space? Well, almost 100% of the water in the station must be recycled. This means that every drop of wastewater, water used for hygiene, and even moisture in the air will be used over and over again. There are systems in there that take that wastewater and pull the stuff out of it that would be considered the waste and recycle the water. So you're going up there and you're gonna drink the water that was in your pee at some point. You're going to drink the water that somebody exhaled out of their mouth at some point, because you're not shipping water up to the space station every week because it's way too expensive at this point. Storage is also a problem. So making recycling is better. Maybe we could get away with having a 50,000 gallon tank attached to the space station, but how are we going to get it up there? How are we going to attach it? How are we going to fill it? Maybe it's better if we just recycle. And that's what they decided they would do. The main functions of the life support system, including recycling wastewater. They're using water to produce, or using recycled water to produce oxygen. They remove carbon dioxide from the air. They filter out microorganisms and dust from the air, which can cause problems. And they keep the air pressure, temperature, and humidity stable. That's what the life support system of the International Space Station does. So these are a couple of videos again in your playlist that are talking about Chris Hadfield talking about what he's got going on in space. So one of them is him brushing his teeth and how he does that up in space, and it's interesting to think about how different it might be and how to use a washcloth up in space and what happens to water up there. Okay, and then this is another one on how they a little bit more talk about how they do the recycling of water in space. Okay, so that's another consideration for you guys. The other thing that they have to do is they have to produce oxygen. You know, we know that humans need oxygen to live, and so they do that by taking water again and they electrolyze it, which means they're basically running electricity through it, and they're splitting H2O into H2 and O2. Okay, so they're running it through a system that produces oxygen, and that oxygen is then being used, and then the hydrogen is vented into space because hydrogen is an extremely flammable gas. So, well, so is oxygen, but the oxygen can get diluted into the air and makes it a little bit easier for them to manage. So this is what they would be doing if they want to produce oxygen, is they would have a series of things going on, but there'd be an oxygen generator system, which would take water and electricity, split it into hydrogen and oxygen. That oxygen becomes part of the cabin air. We might be able to actually run the hydrogen through a reaction with carbon dioxide that would allow us to reproduce a little bit more water, which could be cycled back into this system, into the water recovery system. We create methane, which could be shipped out because you don't want to really be burning something on the space station, but we'll go from there. All right, so the last bit that I'm going to do to wrap up this what is probably going to end up being a 40 to 45 minute video is talk about, okay, we've gone up into space, we've figured out how to do that. We've tackled some of the challenges of being in space. So for those of us who never get to go to space, what gives? I mean, what is spending these billions of dollars to go to space? What is that doing for us? So we wanted to take a bit of time to show you, yeah, but there are some things that have applications to us here on Earth that were developed out of space technology, kind of thing. One of them is satellites, and the other are materials that are inspired by space age kind of stuff. So let's have a look at this. Satellites, I think, are the most important one for us right now. Satellites are, there's a couple of different definitions out there. So let's just be clear what we're talking about. We're really talking about these artificial satellites. These are satellites that we as humans have fired up into space and are doing something for us. There are also natural satellites. These are small bodies in space that orbit a larger body. Our moon is considered to be a satellite of Earth, if that makes sense to you. But what we're going to focus in on here are these artificial ones, which are small, usually spherical containers loaded with electronic equipment, digital imaging stuff, other instruments that are launched into our orbit, and they perform usually one of four functions. They help us with communication. So they fire they fire communication from one side of the Earth to the other, or they're satellites for observation and research. They keep an eye on what's going on the surface. They do remote sensing, and I'll explain what that is in a second. Or they're used as personal tracking devices, and that's what we call GPS. And I want to get into that in a second. So communication satellites provide wireless technologies for a wide range of applications. The digital signals have resulted in clearer communications and more users having access to this. Anik 1, which was launched by Canada in 1972, transmitted, interestingly, the first television broadcasts by satellite, which I thought you guys might find interesting. I'm going to save a little bit of time for this other interesting stuff. Satellites for research and observation. There are satellites we can put in geosynchronous orbit. That means that we put a satellite up and it always stays above that part of the Earth. As the Earth, turns and as it moves around on its orbit, it's always staying above one spot on Earth. So it's in a fixed position over one part of Earth, geosynchronous. It's synchronized to one spot of Earth. And it moves at the same speed as Earth. And they have numerous applications. We can monitor and forecast weather with them. We can have radar that is being tracked by them. We can follow ships at sea. We can monitor soil quality, track forest fires, report environmental changes, search for natural resources. We can do a bunch of different things with these geosynchronous observation satellites. That's also used for government surveillance, which is probably one of the ones that are military and government surveillance, which you've probably heard about in movies and things like that. So this is just a diagram of what a geosynchronous satellite might look like and what it might be doing. What I think is really interesting is when we get into these ideas of remote sensing and what those are all about. So satellites in low orbit can perform remote sensing, which is a process in which digital imaging devices and satellites make observations of the Earth's surface and send this information back to Earth. So these activities include providing information on the condition of the environment, natural resources, effects of urbanization, growth, those kinds of things. I took a course in university on remote sensing. I don't remember a lot about it, but I remember it being really, really cool what we could do with the information from these satellites. Usually we use the information for planning purposes. We might decide, that this area of environment isn't looking good from space. Maybe we need something to make a plan to protect that environment, something along those lines. So if you wanted to, I don't think I included this in your playlist, but you could definitely look up what remote sensing is. It's really interesting stuff. If you wanted to take a degree in physical geography, you would probably study some remote sensing somewhere along the way. What I really wanted to spend the time talking about is GPS, because if you've got a cell phone, you've got GPS in it right now. GPS stands for Global Positioning System, and it allows you to track where you are on Earth at any one time. And the system involves the use of 24 satellites positioned in orbit, allowing for 3 to always be above the horizon to be used at any one time. And basically, they use the idea of triangulation, where one of them knows where, if you get 3 of them knowing where you are, they can pinpoint your location within a few meters of your actual location. So these satellites provide coordinated location information, which is transmitted to a GPS receiver, usually in your handheld device, whatever it might be, to indicate the person's exact position on Earth. Instead of me waving my arms around, I would recommend you guys watch this short video on how GPS works, because it's really cool to think about it. And it's only 4 minutes of your time to see how that works. The last thing we're going to talk about here then is space age materials inspired or space age inspired materials and systems. So other than satellites, there's other stuff out there that is really cool that came from the space programs that we've had around the world. So they were originally designed for a space application, but now have practical applications here on Earth. What we call spin-offs, and I've got a video you can watch on that, are made use of in the following fields. So things like computer technology, consumer technology, medical health, industrial, transportation, public safety. And what you could do is, if you wanted to, and what I'm going to ask you to do when you finish this video, or if you want to hit pause right now, go to page 431 and select one example for each of the following. So a computer technology, what was it used for in space? How is it used on Earth? A consumer technology, what was it used for in space? How is it used on Earth? Let me give you an example of one that I can't remember if it's on page 431 or not. The UPC codes they have on products, right? These guys right here with those lines, right? Those UPC codes were actually, from what I understand, designed to catalog the hundreds of thousands of parts that were in some of the early rockets or early shuttles, so that if they needed to replace a part, instead of going, oh, I wonder which part this is, they just took a little reader out, scanned it, it told you what part it was, and where to replace it, or where you could find the part, or whatever it is. That was the initial space application for it. We now know that we use that in every grocery store to scan an item to say, hey, this item costs this much. and then we've now linked that into computer systems that allow for them to track quantities of that in the particular store when you need to reorder, whatever it is. So I think that's really cool, is it was used to catalog all of the parts on these space vehicles that were going up initially. Now we've transferred it over to human application. That's what we're talking about, a space age technology having application for us here on Earth presently. So this is just a graphic sort of showing you, and I'm not going to go into details on this, but showing you where we have used different space age technologies to help our lives. Everything from flat panel televisions to breathing apparatuses for firefighters to automatic insulin pumps. All of these things have some sort of material or technology associated with something that was developed during the space age to send people into space or to view space or whatever it might be. All right, so that is the end of what we needed to talk about for this concept. I'm just going to drag this back over and remind you of a couple of things. So remember, there are 10 videos out there for you guys to go through. I would go through them if you've got a few minutes. Just hit the playlist and watch them back to back and really kind of get a sense to what we're talking about. Remember, we talked about three things really in this concept. How do we get people into space? Talking about rockets, payload, fuel, all of that kind of stuff, and and the future of that. We talked about surviving in space. What are the hazards, and how have we overcome surviving and living in space, and maybe where we need to still go? And then space technology, meeting our needs here on Earth. What are some ways that what we've learned to do in space has been applied to us here on Earth? Okay, so those are the three things. So you guys can expect me to ask something from each of those sort of three sections, and for you guys to be responsible for that. So as you guys are moving through and learning your stuff for this section, please make sure that you're taking the time to look for those three separate categories, and then really pay close attention in your notes to the bolded and underlined words that are out there. These are things that are vocabulary words you guys need to know. So what is the payload? What is the fuel? Right? What are space shuttles, space probes, and space stations, and how are they different from each other? So really do pay attention to all of those little details along the way as you're moving through this, but try to connect it to how do we get up there, how do we survive up there, and then why are we spending billions of dollars on this, and what good is it for us? In other words, what are these applications for us here back on Earth? Don't forget to work on, if you do anything, work on worksheet number 3, just concept E3 on that. When you've done that and you feel confident, please move on to the practice quiz in the Google Classroom. Wait for feedback from me, and then when I've said it's okay, head on to that summative quiz. So that's it for concept E3. Hope you enjoyed the video. If you have any questions, please track me down online, fire me an email, come in for one of my office hours, or maybe we can set up a one-on-one Google Meet. That's entirely up to you. And yeah, as always, stay safe, stay healthy, and we will talk soon.